Let's begin to understand image formation by a convex mirror. So the position is front of the mirror. That's all. So there are only two cases. One is in front of the mirror and another one is object at infinity. That's it. So front of the mirror can mean anything over here. So it can be at this point, anything, doesn't matter. So my suggestion is take a very big, almost to the same length as the mirror. You will see why. So the very first ray is one which is parallel. So what will happen? It will come as if it's coming from focus. That is, it will reflect as if it's coming from focus. So this is set of solid line and this is a dashed line. Next, take an object, take a ray from your center of curvature. So this is your incident ray and it will bounce back and go in that direction, right? So any ray which is going towards center of curvature, something like this, right, will get bounced back. So this is the point wherein both the reflected rays are meeting, and that's your answer. That's it. Okay. So this is something like this. So this is diminished, right? So this is diminished. Erect. It's either, is it not? It's same upside. It's up straight, same as that of the object. Is it real or virtual? It is virtual. Where is it located? Behind the mirror. That's all. You need not write it between pole, focus, and center of curvature. It's just behind the mirror. So let's look at the practical pen and paper work of the same diagram. So like usual, you need to draw a line which is around 12 to 15 centimeter. Then mark your 0, 3 and 6. So I'm deciding on that. Yes, 0, 3 and 6. So then an arc of 6 centimeter in length. Then we are going to keep the object. I think I drew it very close. I should have not done that, but it doesn't matter. It's okay. I'm taking 2. You guys can take 2.5 also. It's okay. It has to be a bit big. Don't take very small object. So that's your object. Then I'll take a ray which is parallel to principal axis. So please look at how I'm using the transparent scale to draw a parallel line, right? So you have to do such tricks. So any line which is parallel to principal axis, what happens? It appears to come from focus. Okay, so that's your first ray. Next one, I don't remember. Same thing. That's convenient for me. One which is going towards center of curvature. What happens? So it will bounce back. See, again, be smart. Draw it at one shot. So, and don't forget the arrows. It has to be right. So some people, I've told you this before, they mark the arrows wrong. Light comes from the source, right? Remember that. And that is your image. That's it. Okay, so you can see a diminished, erect, virtual behind the mirror image. So it is imaginary, right? It's not a real image. It's virtual image, so it cannot be captured on the screen. And I have to show the same. Again, I'm not labeled all of this and I did a mistake over here. So I had not marked the mirror actually. So that was one mistake and labeling has to be done. So even this has to be labeled. So you have to be A B, and this is A dash and B dash. Okay, so this is your basic diagram. So where is it used? So let's look at it practically first. I'm sure it something might trigger when you look at that mirror. So please look at this practical. So does it kind of trigger your memory? You would have seen that somewhere. Yes, in vehicles. So nowadays, quite a few people are putting it on their rear view mirrors, right? So for rear view mirrors, convex mirror is used. Why? Convex mirrors enables the driver to view much larger area than you would be possible with a plane mirror. See, this is a pretty big plane mirror. It's around 14 centimeter, right? And this is around, actually I didn't measure. Okay, we'll try doing it here itself. This is half, and this is half of that, and this is half of that. So one, how much? Okay, this is 1/8, I guess. Yeah, 1/8. Is it not? Kind of. No, it's a bit more than 1/8, but anyways, that's kind of pretty small. So this dimension is pretty small compared to your plane mirror. But the vision I have, the things that I can see over here is pretty huge. Again, I'm very close to it. If it was a bit far, if I had taken a step back, a much larger view would have been there. Okay, so point is, yes, it looks small, and that's why that's the reason they would have written on any kind of rear view mirror, industrial one, right? They would have written object is much closer than what they appear. I've seen this. I've read this. Objects are much closer than what they appear. Right? Reason being, just because they look small, they're not far away. That's what they mean. In a plain, simple language, if it looks far away, but it's actually not. It might look far away, but it's actually not. Okay, so this is the reason. You guys got to see the reason theoretically as well. Understanding and with race and all of that. Such big object just in front of the mirror, it will look so small. It's almost half the size, right? So you guys can imagine the advantage of this as a rear view mirror. Okay, so you guys should pretty much copy all of this. And this as well.